Welcome to today's joint lecture. We are going to discuss a really special topic today, where two seemingly distant worlds come together, the most modern artificial intelligence-based software testing and, well, the world of space security. Yes, this is really an exciting topic. Have you ever thought that in the systems where the slightest mistake can cause a catastrophe, like space technology, how do they guarantee reliability, especially if the system itself is based on it? Exactly, this is the big question of the day. We are going to take a closer look at two new research materials that are closely related to each other, which you have shared with us. Both are the work of Ferenc Langmuir, and they are quite new. They were created in October 2025. Are they really new materials? One of them presents a platform called PersonaGenius AI. This is a self-developing system that works with multiple AI processors. Originally, so to speak, it was developed for the generation of realistic users of Persona and complex software for hybrid testing. And the other one? The other material is a developed space security framework. And here comes the real twist. I'm curious. The reliability and accuracy of this complex financial and risk assessment model was tested and validated with the help of the PersonaGenius AI system. Wait, so one of the materials evaluates the other? Or at least the model that describes it. This is quite meta. In most areas, such as space activities. So let's see how they use the material, not only to build systems, but also to monitor them. Exactly. This is a great example of this. All right, then let's dive into the materials you sent. We will focus on what is the most important lesson from these two studies. How does this MI tester build up and work? And why is this type of validation and space security important in a complicated world? Let's start with the basics. Yes, let's start with the basics. Why was it necessary to develop such a new type of complex testing system? Aren't traditional methods enough? This is a legitimate question. Well, traditional software testing methods, think of manual cuttings or scripted, fixed-running automated scripts, are increasingly struggling with the complexity of today's software, especially if they change. This is especially true for systems that also contain artificial intelligence. Since they constantly change, learn during use, their behavior is not always completely predictable. A small change on the user interface or a refresh of an AI model behind it can easily open up old tests. I see. So dynamic learning systems need more dynamic testing. Logical. And the studies also mention the problem of personalization, which is also related to it, isn't it? Yes. The usage persons created by traditional methods, which are used, for example, during marketing or user experiment planning, are often overly general and static. They don't necessarily reflect the real user's behavior diversity and diversity. So, they're not quite vivid enough. Exactly. And this is where the PersonaGenius AI comes into play. This is a new generation platform, which serves as a software, so it works in 100 models. It is able to generate realistic, dynamic personas, but it can do more than that. It also has a complex, hybrid software testing system. It is also able to monitor its own and external softwares. This approach to the multidisciplinary sounds particularly interesting. What does this mean in practice? As if a team was working together? Or how should I imagine it? Exactly. The soul of the system is a team of AI business leaders, where each business type has its own specialty. The three main types of learning are different. There are reactive business leaders. Reactive. Yes, they're the masters of rapid response. They immediately respond to changes in their environment, for example, to a pop-up window or an error message. According to the source, they usually respond in 23 milliseconds, which is lightning fast. Really? But they don't have memories. They only focus on the given moment. So they are the reflexes of the system? I get it. Pretty much, yes. Good analogy. Then there are cognitive business leaders. They are already able to do more complex tasks, such as recognition, learning from past data. They already have a memory and are able to analyze previous test results. For example, they recognize if a test is flaky. That is, they can't trust where it's successful, where it's unsuccessful. This is needed to analyze historical data. They are looking for connections. Well, I get it. And the third type? What is their role? They're the reinforcement learning, that is, the RL business leaders. Reinforcement learning. They are the strategic thinkers, based on test luck, learning from received feedback, recommendations, and punishments. They develop the most effective testing strategies. So they optimize? Yes. Their goal is to maximize long-term recommendations. This can be, for example, the most possible and most serious error discovery in the shortest time. The study mentions the Q-learning algorithm, which helps business leaders to learn which step in a given situation, let's say, which test run, has the best result for the future. All right, so we have these three types of specialist business leaders: reactive, cognitive, RL. But how do they communicate with each other? How do they coordinate their work? Because they have to work as a team, right? This is where the blackboard or virtual board concept comes into play. This is a shared memory area, a kind of digital message board. Business leaders write down the relevant information here. What did they observe? What tests did they run? What results did they get? What problems did they notice? And they read the others from here? Exactly. They read the information shared by others from here. They don't have to send messages to each other directly. This is like an online project management tool where everyone sees the tasks and progress. Something like that. Very good analogy. This approach has several advantages. It's very flexible because business leaders can work in asynchronous or even in parallel. And what's important, it's error-proof. Error-proof. How? Well, if a business leader is fired for some reason, the others see the last state on the board. And the system is able to redesign, take over the tasks, or at least pay attention to the failure in the further strategy. In this way, the system is able to adapt to unexpected situations. Brilliant. And the study also mentions another, well, really impressive ability: self-healing automation. This is one of the most interesting aspects, yes. It means that the system not only completes the tests, but is able to notice if there is a problem while running. For example, a button or menu item changes after a refresh on the user interface of the software, which would cut down the traditional scripts right away. Exactly. The Persona G suite is a great example of self-healing automation. In this case, the engineers, the managers do not give up, but automatically try to adapt. They are looking for other methods to identify the element. They are trying out another locator strategy, as the professional language says. This 99.2% ratio shows that the overwhelming majority of the obstacles during the test run could be solved in the system without human intervention. This is really eye-catching. I hope so. I think this could mean a huge amount of time and cost-cutting in practice. Engineers do not have to spend hours on improving the tests after every small change. Absolutely. But why is this especially important in our context? For you, the listener. Because the softwares and models that this system is able to test, such as the soon-to-be-released space security framework, are incredibly complex. And the risks associated with them? Well, they are huge. Yes, there is no room for error here. A hidden error in such a system is not only a frustrating software problem, but it can potentially endanger a billion-dollar loss, a complete space mission, or even human lives. A self-healing, adaptive, and intelligent testing system like PersonaGenius AI can drastically reduce this risk, because it is much more basic. It is much more basic, reliable, and faster to monitor these critical systems than it would be possible with human or traditional automation. I see. So we have a truly advanced MI testing tool. Intelligent processors, common workspace, self-healing capabilities. All this to compensate for the complexity of modern software. Exactly. And now let's turn to the field where this system was introduced live, as described in the study sent by the other agency. And this is nothing more than the world of space security. This study is also from Ferenc Lengyel, the 2025 October extended version. What makes space security such a special and challenging field? Well, space economy is growing rapidly. More and more satellites are orbiting the Earth, commercial space stations are being built, space bases are being designed, and tourism has also appeared on the space border. Yes, the traffic up there is getting bigger and bigger. According to the source, This market could reach $35 and $46 billion by 2040. This growth is full of new and unique security challenges, and the risks are extreme. Just think about it. A single unsuccessful launch of a rocket or a larger mission can cause billions of damage in itself. And then we haven't even talked about the dangers of the operating environment, the danger of cosmic radiation, the impact of micrometeoroids, the extreme temperature fluctuations. These can all damage expensive devices. That's right. Or the increasing risk of collision due to space debris and the risks of space travel, such as a stronger magnetic field, which can destroy the electronics of satellites. That's also a serious risk. Exactly. For these very special and high risks, traditional ground-based security models simply cannot be used. They do not work. This is why the study recommends new, advanced risk assessment methods. What are they? One of them is the statistical methods of analysis and machine learning. The point is that the system does not work with a fixed risk assessment, but constantly learns and fine-tunes its predictions as new data arrives. What kind of data do you mean? For example, the status of ongoing missions, the change of environmental conditions, or even the previous challenges of similar devices. In essence, the system keeps the risk knowledge up to date. It is constantly refreshing. They also mention survival analysis. What does it do exactly? Survival analysis models how long a device, such as a satellite, can work reliably. The study mentions the Weibull model, which is an integrated statistical device for the analysis of life contents. It is especially good if the risk of collision is not constant over time. I think this is common in space. Yes. Consider that some creatures may be more willing to make a mistake at first. Others only get tired after a long time. This helps insurers better assess how long a given device has a guaranteed period of time in reality. The study also includes specific tables about possible survival probabilities for different types of missions. And of course, I think machine learning cannot be left out. What specific algorithms are used? Well, of course. The study mentions several advanced machine learning techniques, such as random forest and gradient boosting, as well as neural networks, specifically MLP regressors. Standard devices. Yes, but what is interesting is that these are not used separately, but combined into an ensemble model. This is a practical and effective method in machine learning. By combining the predictions of several models operating on different principles, we usually get more accurate and reliable results, as if we were asking for multiple expert opinions. Exactly, as if we were relying on only one model. Okay, so the risk is assessed with advanced models, but the study does not stop here. It also recommends financial innovations, right? That's right. This is also an important part of the Eastern system. For example, so-called space travel-generated products are recommended. What is that? It sounds pretty wild. Well, these are financial contracts that are linked to a special space-time risk index called WRI. This index must be imagined as a single number that summarizes relevant, current space-time data like, say, the level of sun activity. Yes, for example, the level of sun activity, the strength of geomagnetic storms. If this index rises above a certain level, it can activate the insurance payment. I see. The source also shows a specific example of a case of optional pricing based on such an index, where a $10 million protection gift came out to about $1.85 million on the basis of the model. Serious money. And they mention securities linked to insurance. Insurance-linked securities. ILS as well. What does this mean? In short, these are essentially financial instruments that make it possible for insurers to transfer some of the extreme, catastrophic space insurance risks to the stock markets. For example, to institutional investors. So they spread the risk. Yes, this helps insurers to better handle the huge potential costs, diversify their portfolio, and increase their capacity on this very special and demanding market. And here we come back to our starting point. How does all this relate to the previously detailedly discussed PersonaGenius AI test system? Where's the connection? The study very clearly states that these extremely complex risk assessment models and the new financial instruments seem to be good in theory, But before practical application, they're extremely basic testing and validation. And this is where PersonaGenius comes in. This is exactly what PersonaGenius AI has been assigned to do, its multi-processor testing system. The source states that the entire space insurance framework, along with all its models and components, has been validated and refined through 14 iterative trial cycles with the help of PersonaGenius AI. Through 14 cycles. That's not a small number. In essence, one MI is monitoring and refining the other, the system that models financial risks. And what was the result of this validation process? What does PersonaGenius AI mean? The results are really convincing. The identified problems during the testing cycles managed by the MI, whether they are errors in the code, inaccuracies in the models, or even the lack of the user interface, managed to solve 95.2% of the problems. Wow! And this improved the overall reliability and accuracy of the framework system. The risk models based on machine learning averaged an average accuracy of 85% at the end of the validation tests. And what did this mean from a business point of view? Is there any data on this?
There is.
According to the study report, the use of the validated and refined framework system can lead to 15 to 22% accuracy for the providers. That's nice. What is particularly interesting is the dynamics of the learning process. During the 14 iteration cycle, the performance of the models improved dramatically. In the first iteration, the ensemble model accuracy mentioned was only around 65%. At the end, it was 95%. Yes, but at the end of the process, it reached 95%. This beautifully demonstrates the power of iterative AI-driven testing and refinement in the case of complex systems. Is there a more concrete, tangible example in the study which helps to imagine how this works in practice? Yes. Fortunately, they also presented a case study, a risk of a suborbital space tourism mission, and modeled the calculation of the risk of a suborbital space tourism mission. Oh, that's interesting. There was a 3-hour route that reaches the 100 kilometers altitude of the space border with 6 passengers on the surface with a reusable spacecraft. Based on the framework system models, the total risk value was estimated at 0.001089. That seems quite low. Yes, and they deduced from this that the insurance fee for one passenger is approximately $1,089. Thus, the total insurance for the mission would be $6,534. The risk level was estimated as low. This shows how the system can be used to meet the requirements of specific or new space activities insurance. Exactly. All right, then let's try to summarize and synthesize what we have heard. If we connect the two studies, what is the main picture that emerges? What do we take with us? Well, what we see here is an extremely modern and efficient feedback loop. On the one hand, they develop a very advanced artificial intelligence system, the PersonaGenius, which is able to intelligently test complex software and even improve itself. This is one side. On the other hand, this cutting-edge technological device immediately incorporates another, also extremely complex and large-scale system to validate and refine new space insurance models and financial tools. So the tester validates the model? That's right. With this, they practically verify both development value and capabilities. The MI tester proves its productivity on a real, critical problem, while the reliability and accuracy significantly increase thanks to the basic MI-controlled monitoring. I think this type of validation by MI could be key in the future. This synergy is really impressive. What were the most surprising or most interesting moments in these materials for you? For me personally, the teamwork of the MI manager on the virtual table and its over 99% self-healing ability was really, well, mind-blowing. These are really remarkable technical details. I was also impressed by how quickly they used this development testing technology to validate such a special, almost futuristic area of financial models. And they didn't stop at the theory. They showed concrete results. Yes, they showed concrete, measurable results. The high pre-indication accuracy was 85%, the significant problem-solving rate was 95.2%, and the manual business use was 15 to 22%. This shows that this technology is no longer just a laboratory experiment.
It is a practice.
Of course, as is customary, the students probably don't listen to the challenges, do they? What difficulties did the developers indeed? The students honestly talk about some practical challenges and how they tried to deal with them. One of these is the question of explainability, a familiar problem. The black box. Exactly. In the case of an MI system or an ensemble machine learning model, it is sometimes difficult to say exactly why it made a given decision or indication. This is important from the perspective of trust and accountability. And what is their solution? As a solution, they recommend the use of simpler so-called placement models, which can be used to try to make the complex system behave in certain situations understandable. The black box problem is a classic challenge in the field of MI. What other difficulties do they mention? Another significant factor is the computational requirement and scalability. These developed MI systems, such as the PersonaGenius and the complex risk models, require a lot of computational resources, especially in the case of large amounts of data or many parallel tests. And what do they recommend for this? For this, the students recommend the development of hierarchical system architecture and the use of infrastructure, which makes it possible to scale the system according to the current development. So they run it in the open air? Yes. And the dynamic, often unstructured data processing and calling, such as the processing of real-time sensor data or user interactions. For this, robust data processing techniques and continuous learning capabilities were built into the system. And the ethical aspects? That's what they're talking about. Let's say at the persona generation. Yes. They also mention one of the ethical aspects, especially the risk of bias in the persona generation, as a solution of bias detection methods and decency requirements. Okay, let's dig into this in more detail. What is the most important message that we can take with us from all this? What's the point? Perhaps the most important lesson is that the role of artificial intelligence is transforming. It's not just that EMI operates our systems, but that EMI itself is becoming the key tool for monitoring and validating so EMI monitors EMI or EMI-controlled systems. Exactly. This is especially true in extremely high-risk and complex areas, such as the discovery of the universe, and the use of technology EMI helps to deal with the complexity that it itself creates or confronts. And if we look into the future, what do you think is the next step in the field of quantum computing or blockchain technology? Well, what's really exciting here is that the space is becoming more and more commercial and more complex business plans are emerging. Let's just think about systematic interplanetary travel, asteroid mining, or large private space stations. A lot of sci-fi stuff that is slowly coming true. So these autonomous validation systems also have to keep evolving. The question arises, how can these EMI-based testing and validating systems keep up with the exponentially increasing complexity? Good question. Will it be necessary, for example, for quantum algorithms to optimize the real-time of huge risky portfolios? Or maybe for smart contracts, which completely automatically and unquestionably arrange the demand for debt on the basis of real-time data after a remote asteroid mine accident? These are extremely exciting open questions for the future. Really thought-provoking perspectives. Thank you for being with us in this basic analysis, and thank you in particular for providing us with these really interesting and educational resources. You're welcome. If you are interested in the topic in the studies and the Facebook post, which we also got from you, you can find the demo versions of the systems shown in the video description. We hope you found this insight useful and exciting about how the artificial intelligence and the space insurance and the special, future-revealing industries.